start with the next topic, that is periodic functions and Fourier series. So before we begin, let us define what a periodic function is. As you can see, a periodic function is periodic if it is defined for all values of theta, and if there is some positive number t such that f of theta plus theta is equal to f of theta, then we say it is a periodic function. Examples are these. As you can see, this is the time period, and this time period is getting repeated. Next, square wave, the time period, this is getting repeated. This is an example of sawtooth wave, which is also a periodic wave. Fourier series. What is this Fourier series? Any given function can be expressed by using Fourier series as a summation of cosine and sine terms. So it can be represented by trigonometric series. Mathematically, the equation can be written this way: that f of theta is equal to a0 plus summation a n cos n theta, where n is running from 1 to infinity, b n sin n theta, where n is running from 1 to infinity. So that means it is consisting of a constant term, cosine terms and sine terms. This is how any given expression is expressed. So now, what kind of trigonometric functions are we talking about? Cos n theta means cos theta, cos 2. N is equal to 1 means cos theta. N is 2 is 2 theta. N is 3 is 3 theta, and so on. Sin n theta is sin theta, sin 2 theta, sin 3 theta, and so on. So how do you represent this? The red line, as you can see, is cos theta. The blue one is cos 2 times theta, cos 3 times theta. So the phase angle is theta, 2 theta, cos, this is cos theta, 1 time, 2 times, 3 times. The phase angle is getting, angular velocity. That part is increased, so frequency is reduced. Cos 0 is 1. This is cos, this is pi, cos 90. Cos pi, cos. So cos 0 is 1. Okay. Cos 90 is 0. Cos pi is minus 1. Red one. Then cos 3 pi by 2, again 0. Cos n pi by 2 is 0. And cos 2 pi is plus 1, so it's going 1. Similarly, the red line is cos, blue line is cos 2 theta, and the next one is this, sin 2 theta. So now, sin red line, sin 0 is 0, sin 90 is 1, sin pi is 0, sin n pi is 0. Okay, and then sin 3 pi by 2 is minus 1, and so on. Same way with the phase difference of theta, 2 theta, like that it is shown. Now how do you determine? When you can express any given function as a series of cosines and sines with the coefficients a n and b n, there should be a way to determine these coefficients. So to determine this, we need to make use of some of the trigonometric functions, that is integral of minus pi to pi cos n theta cos m theta d theta. Cos a cos b can be written as cos c plus d plus cos c minus d by 2. Because this is 2 times of this is this. And again integrate between the limits. When you do this, this will result in cos n theta which is equal to 0 when n is not equal to m. And when n is equal to m, it is equal to pi. That means cos n theta, if n is equal to m, it becomes cos square n theta. When it is cos square n theta, what happens? It is pi. If it is not equal, it becomes 0. Another important relation is with respect to sine. Integral of sine n theta cos n theta within the limits minus pi to pi can be written as sine n plus m and sine n minus m by 2. Integrate it by parts, and this equation is 0 for all values of n and m, whether they are equal or not. And sine n theta is written as cos n minus m and cos n plus m. Integrate them, there is a minus sign in between. This is 0 when n is not equal to m, and it is equal to pi when n is equal to m. So with these values, let us see how we determine the coefficients of Fourier series. Integrating equation 1. What is equation 1? a0 plus this, what is written in the bracket, is equation 1. Now integrate this within the limits minus pi to pi, f of theta d theta, a0 plus this, and by making use of our relations, this becomes equal to, this is 0, this was 0, as we have seen in the earlier trigonometric relations. This is finally resulting in only integral minus pi to pi a0 d theta. When you integrate this is what you are getting, and hence a0 will be 1 by 2 pi of this equation. So a0 therefore is nothing but the average value of this function over the interval between minus pi to pi. Minus pi to pi is also equivalent to integrating within the limits from 0 to 2 pi. So if you write this, it becomes like this. So it's alright as long as integration is performed over one period, so you can replace it. This is what you are getting, 0 to 2 pi, 0 to 2 pi of this, 0 to 2 pi of this. This is 0, this is 0. Once again you are left only with this function, and a0 is equal to 1 by 2 pi 0 to 2 pi f theta d theta. To determine an, this equation what we are considering multiplied with cos n theta, and limits are minus pi to plus pi. This term is cos n theta term is 0. Then you have cos n theta term, which is equal to a n pi. Third term is 0. This is what you are getting. So determine this. Once again, this is 0. Second term is 0. This is 0. b n pi. Therefore, the coefficients are a0 is given by this, am is given by this, bm is, if you remember this is enough. How do you calculate a0? How do you calculate am? Whatever be the given function, multiply with cos m theta d theta and integrate between the limits minus pi to pi. To determine bm, given function is multiplied with sin m theta and again integrate within the limits. The integration can be performed from 0 to 2 pi instead. Same thing, 1 by 2 pi, 1 by pi, 1 by pi. For example, if you take Fourier series of the following periodic function, the value, as you can see, between the limits 0 to pi the value is plus a, and from pi to 2 pi the value is minus a, and it is repeated. And f of theta plus 2 pi is f of theta. Therefore, it is a periodic function. So once again, a0 by using this formula, f of theta between 0 to 2 pi, which is divided into 0 to pi and pi to 2 pi, and from 0 to pi the value is a, and from pi to 2 pi the value is minus a. So when you integrate, this is a, this is minus a, and hence it is 0. Now to evaluate an, we have already seen, multiply with cos n theta. The function is from 0 to pi it is a, from pi to 2 pi it is minus a, and integral of cos, a is only a constant, integral of cos n theta is sin n theta by n, and integrate between these limits, it becomes 0. Now to determine bn, you have to multiply it with sin n theta. So integral of sin n is cos n by n here too, and then when you multiply what you are getting and integrate and apply the limits, what you are getting is cos n theta by this. So what relation you are getting is just equal to minus cos n pi plus cos 0 plus cos 2n pi cos n pi. And what you are getting is a by n pi minus cos n pi plus cos 0 plus cos 2n pi minus cos n pi. This is 1, this is 1, this is 1. So this is 4a by n pi when n is odd. What happens when n is even? When n is even, this is even times it is minus 1, this is 0, plus 1, minus 1, so it is 0. So therefore the corresponding Fourier series is 4a by pi sin theta, sin 3 theta, sin, and so on. So we may not be able to consider infinite number. You cannot have n to be infinity. Then what should be the value of n? What value should you take? So how do you know which value you must take? Let us consider different values of n and then see how the Fourier transform is looking. So if you take n is equal to 4, 1, 2, 3, 4 terms, this is how you are getting. If you take 6 terms, 1, 2, 3, 4, 5, 6, this is how it becomes. If you take, as the number of terms are increasing, see what's happening. If you take 12 terms, so combining these two, 12 terms is a blue curve, the red is with 12 terms, blue is drawn with 4 terms. So it is more the number, more approximation, more closer. same way. Now the red curve is drawn with 12 terms, blue curve is drawn, same thing is shown here. Now 20 terms. So actually you are comprising the given signal consists of so many terms. So actually this signal is used in practical purposes to represent the data or the information. So when the information is being transmitted from the transmitter to the receiver, it consists of so many different components, and these are known as harmonics. Okay, so that is why the Fourier series is very important. Now let's also define two things called even functions and odd functions. The value of the function from origin, if you go magnitude of some distance on the x-axis onto the right, the same distance onto the right and as well as left, the value remains the same. When we walk, that means going towards positive x-axis, going towards the negative axis, the value remains the same in both directions. Then it is said to be an even function. So f of minus theta is equal to f of theta is mathematical definition. Then that given function is called as an even function. Odd function, the value of the function will change its sign but with the same magnitude but opposite in sign. So here let us say that this is 5 degrees, this is negative maximum, minus 5 degrees it is positive maximum. So by definition f of minus theta is minus f theta, then it is an odd function. Even functions can solely be represented by cosine waves because cosine waves are even functions, and sum of even functions is yet another even function. Odd functions are solely defined by sine waves because sine waves are odd functions. So sum of odd functions is another odd function. So the Fourier series of an even function is expressed in terms of cosine terms. The Fourier series of an odd function is expressed in terms of sine terms. Let us take this is an even function. Okay, f of theta plus 2 pi is equal to f of theta because the periodicity is 2 pi, and if you integrate between the limits, what you are getting is pi squared by 3. An, use integration by parts. When n is odd, this is what you are getting. When n is even, you are getting this. We are making use of the trigonometric relations. Therefore, Bn is 0 because it is an even function. So corresponding Fourier series are given by cos all this. So functions having arbitrary period. Till now we were discussing about a square wave or fx is equal to x square, which is having a period, which are periodic functions. Suppose you are wanting to find out the Fourier series for an arbitrary, for a function which has arbitrary period, we can relate this like this. So angle is written as angle theta is equal to omega t, angular velocity. Omega is 2 pi f and f is 1 over t. Theta is 2 pi ft, so theta is 2 pi by t. Theta given by this, so d theta will be 2 pi by t dt. Change the limits of integration. Minus pi means minus 2 pi by dt, isn't it? So therefore, what is pi from here? Pi from here is 2 pi. So therefore, t is equal to minus t by 2. Theta plus pi is theta d by 2. So when you are integrating between minus pi to pi, it is in effect integrating between the limits minus t by 2 to t by 2. See. An, again, pi is t by 2. 2 pi is t, pi will be t by 2. And theta is replaced with the t. This is 2 pi n by t t. So this is with respect to angle, this is with respect to time. Bn is given by this. So let us see this function. Its value is t between the limits minus t by 4 to plus t by 4. Okay, and it is minus t plus t by 2 for t by 4 to 3t by 4 between these two limits. So for this function, f of t plus t is this. It's an odd function. So this is 0. Bn is calculated using this relation. Okay. Bn is calculated like this. Use integration by parts. You are dividing this integral between 0 to t by 4, t by 4 to t by 2. When you integrate, this becomes 0. So n is an even function. Therefore, the Fourier series is given by this. The complex form of Fourier series is given this. So, by using the formula cos theta sin theta, the nth harmonic can be expressed as this, which can be given by this, right? Cos n theta, combining and denoting Cn by this and C minus n by this, C0 is equal to A0. We get a relation like this, and the Fourier series can be expressed in terms of this. Cn and C minus n are called complex conjugates. The values can be evaluated like this, where n is equal to 0, plus or minus 1, plus or minus 2, and so on. The complex form of the Fourier series is given by this. So if you want to find the Fourier series of this function, as before, a is equal to 5 you take. For this, a0 is 0. For n is equal to 1 to 8, calculate. Again use trigonometric relations. This is what you are getting. Bn for 8 values. So the complex form of this can also be expressed like this. Cn is like this. I'll evaluate the constants up to 8. This is what you are getting. Thank you. This is how a Fourier series is calculated. Thank you.